Okay, welcome to my presentation for Game Engines Project 2, Animation Commands and the final exam prep work. Let's get right into it by showing off the thing. Okay, so our little scene shows up here, and everything just disappeared from behind it for whatever reason. Um, so yeah. So, to begin the first batch of animations, we press R, and we can see that Navi's flying around, looking around. And with that batch done, everything stops, and I can press R again. And if I mash R while this is playing, nothing happens because the animation's still going. So we can't move on to the next one. Finally, we can play the last one, and wow, Navi's woken up Link. Cool. So this is configurable from this external file, scene anims. So showing off, I am showing off the move distance, the move over time. I believe I'm using orient over time as well. So this third move, the move where Navi was moving away from the camera the second time, was actually a move over time. To show that off, let's make Navi move way faster by reducing the amount of time Navi moves over. And I don't know, to show this is configurable, let's make Link rotate the other way as well. So Navi's commands here, oops, wrong button, Navi's commands here are run in parallel. And again, the second batch, the commands are run in parallel. But when we wake Link up, they're running in serial. Which I guess sort of comes to one of the things I'm unsure of. When I was reading through the paper, I read it as parallel being sequential and serial being in tandem. But thinking about that either like last night or today, I was like, wait, shouldn't serial be sequential and parallel in tandem? I didn't change it, but I did make a note of it in this video and here in the README. So on to how this code works and how we'd actually use it to do different things. So we have these scene animations here, which line up to most of the information in the command. The only thing that doesn't line up is a target mesh for like a follow command. Although I suppose something that could be done is like how I'm storing the owner of the animation. I could also like store a reference to the idea of the thing it's following, and then when I load them in, which is right here, I would just have another lookup to go grab the target. And then this also, the executed, does not have an equivalent in the JSON because the animation should always default false. But anyways, so going from this JSON here, we read it in using the IO handler. In the main, that is called after we make all the models. So here's us making the lights, here's us making the models, yada 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 yada. Yeah. So we read in the models, we texture them, and then after doing all of that, we actually read in the animations. Something that might want, or like might be wanted to do is after you read them in, you sort them like by batch to make sure everything's in the right order. But for the purposes of this, I've just made sure they're always in the right order in the JSON. But they all get read in. Uh, read many anims. So we just create a command, we set its properties to be what we grab from the JSON, and then we push it back to our list of commands. So, moving on from there, we then have sorry for all this dead air and then me just filling it with random music cues. But yeah, when key R is pressed, we attempt to go to the next frame, which is just this method here. So, right here, we check to see if any animations are still being executed. Because if there's still animations being executed, we don't want to move on to the next batch of animations. However, if they're not executing, we can move on to the next frame, in which case we go through and we read in all of the animations associated with that batch, and then we assign them to the correct mesh. And then, so assigning these animations to a mesh is done through these entities, which have a queue for the parallel commands, because since they're meant to be sequential, a first in, first out object makes the most sense. The serial, they're all being operated on at the same time, so we just use a vector. But anyways, back to loading them in. We load them into the right storage container, and then we go through and tell each to execute. Now, in a given batch, the model can only be executing from its parallels or from its serials, not from both. Which makes sense because if you wanted to execute parallels while executing serials, that would just be executing more serials. Okay. So, from there, we go into the entity. They're told to execute And all that really does is say, hey, if I have commands to execute and I'm not already executing them, go ahead and execute them. Then, to actually go through the executing of them, now that we've gotten all of that hullabaloo done, right at the beginning, we tell the entity to process any commands on it. Which brings us to this method. So, for parallels, it goes and finds, hey, what kind of command is this? It does the running associated. When that's finally been executed, it removes it from the list. It says, I'm no longer executing. However, if I have another thing to execute, let's go and do that. For the serial, we do some Boolean math, but basically it goes down and checks if any of its commands are still executing. If it's still executing, continue executing it, and then, hey, I'm still executing. So, we can't be done yet. Okay. So, how do these things actually happen? A lot of it is basically the same math over and over again. So moving over distance, we get the direction, we move by our speed, and then we check if we're close enough to our destination that we can stop moving. This sort of little grace zone is because if we're just using the exact position, there's a good chance we'll move past it, simply because of the nature of, using delta time and a speed. We can't move perfect always. So for the move over time, where we don't have a speed defined, instead we have a time frame where we want to execute the thing. So we get the direction, we also get the distance beforehand, and then we divide the distance by the amount of time we want to move that distance. And then we reduce time by delta time because we've now moved that distance for that time. We no longer need to factor that into our calculation. Because otherwise we would, I believe, just end up slowing down slightly and slightly over time. And then, if time is less than 0, we've executed, we're fine. It's largely the same with the orientation stuff, just using orientation instead of position. Follow is the same, but instead of using the target from the command here, we instead grab the target mesh's location and use that. What am I trying to say here? I don't have an example of this, but since it's basically the same math, it works. And then trigger basically uses the speed as like the radius of, hey, if I'm this close to whatever point, then I've triggered. You don't want to use a trigger in the parallel, only in serial, because otherwise it's just going to execute the trigger forever, but it's not moving at all, so that trigger can never become true. I guess unless you're moving like the other object it's comparing itself to or something. Um, so, more complicated stuff. The move by waypoints would just be a bunch of move distance commands in parallel. Um, if you wanted to do like an ease in, you could have like a super short move over time that's like just run for a couple frames to make the first couple steps slower, um, and then have a move distance command right after that. So it would then like speed up. Um, I don't know. What's some other stuff? I think that's most of the stuff you asked. And this video is probably quite long by this point. So I'm going to say that's everything. See ya.